Hello and welcome to today's webinar. We're going to talk about the calculation of stories in RFEM 6 using our building model add-on. My name is Jasmin Hartung. I'm today's moderator. I work for Dlubal Software in marketing and public relations. Today I'm accompanied by my two colleagues, Bastian Kuhn and Stefan Frenzel, who can now introduce themselves. I think we should start with Bastian.
All right, thank you. Yeah, my name is Bastian Kuhn. I'm responsible for the development of any add-on related to timber design and also customer support.
Yeah, hello, my name is Stefan Frenzel. So I work here at Dlubal in the development of the dynamic add-ons and of course in the customer support. And I will answer your questions during the webinar today.
Okay, thank you very much for the introduction. We can now turn off our webcam so that the customers can see the whole screen. Okay, before we start with our webinar, I'd like to add that you can ask questions during the presentation. For that, you can use the control panel that you can find on the right side of your screen. Here you have a field where you can enter your questions, and we will try to answer them during the webinar. If for some reason there are too many questions for us to answer, we will send you your answer via email. And if you just want to listen to the webinar for now and want to ask a question later, you can do so by sending us an email to info@dlubal.com. So now I would hand over the screen to Bastian Kuhn.
Right, yeah, just let me grab the right one, this one.
Yes, I can see the program now.
Perfect, there you go. Okay, before we start with the program, small introduction. What I would like to show you, yeah, for the content, I will show you the building model add-on. Oh, that was too quick. The definition of stories, the modeling, what it's up there with the stories in rigid planes, the results in stories, and how you can get forces and how you can use them later on in the design add-ons. Before we go to the program, I would like to refer to our homepage and explain you a little bit the project that I want to show you. The project that I remodeled here is an 18-story mass timber hybrid student residence in Canada. It was built in 2017. It was in that time the highest building made from timber in the world with 53 meters. But right now there are higher ones. The structure was made from concrete in the stairs in the kernel, and then the CLT plates and the beam columns were attached to this center. I modeled this structure in this webinar. Here it is from last year September, so therefore I will not show you the modeling process of it. If you want to see that, you can watch this webinar where it's about CLT plates, and my colleague Adrian Langhammer also used this model in the construction stages analysis, just for your information. So this is the first model that I would like to show you. And when I showed you everything that's possible in the customer version with this model, I will switch to a pre-release version, and I will show you what we want to do in the future with this add-on, so what you can look forward to. Okay, first of all, the building, here it is. Maybe I can switch on the rendering. So you see, yeah, the first story is made from concrete. The other one is made from timber columns with a size 350 of 350. And here's the concrete kernel. The dimensions of it, I can also add, is 55 meter in the global X direction. And I know it already, but I want to show you 14 meter in the Y direction. And yeah, the stories I said to you already. Now, when you are designing such a building, that's also mentioned in the webinar from Adrian, it is very important to look for the construction stages and also the how to read out the results of such a clearly constructed model can be quite ambitious, and therefore we invented this add-on building model. As always, we switch this on in basic starter here in add-ons and their building model. And when I select OK, so far nothing changed, which is the idea of RFEM 6 right now, that you do not have a specific add-on, but that all the add-ons are integrated into the GUI of the software. But here you see that there's an additional box called building model, and you have that also here in the columns where structure and then building model. They both do more or less the same. So when we select here a new building story, we go into the dialog. I just switch the rendering on so that we can see the whole building there, and we choose the first elevation, the bottom ground floor, and the height of it is 2.9 meter. And now I can actually or more or less automatically choose higher building stories, and they are all generated automatically. In case one story has a different height, you have here the option to modify the height that's generated by this add-on. Click the top button on proportionally. Also, the height can be changed, the effective or the clear height. And maybe an interesting choice, not for this timber building, but for the building that I will show you after this, it's a concrete building, is a rigid diaphragm. I will just leave that on now and integrate all the stories. Where have we been? Story 5, 6, 7. So we need, I mentioned it already, 18 stories, but we have 0 there, so 17 stories would be enough. So there we go. Okay. Oh, you see, there was one too much. That screwed it up a little bit. Okay, now they are all done, all the stories. I get in here an information for each story. Maybe most impressive would be the ground floor, but we can also look that in the mask. And you see right here that we have now a center of mass that you have in the structure, which is perfect for any kind of dynamic analysis and what we did not have before. We have an automatic generation of the stories in here. That was what has changed. And when you go to the visibilities, we have also automatically generated building stories. And when we activate second and third floor, for example, we can just look at them, and then I will also switch off the rendering. You see that this option here, that's called rigid diaphragm, has generated in every story a rigid diaphragm, and which goes to every FE node and where it's connected rigid with all the nodes. As I said, for timber building, it is not sufficient because we have quite a higher slip and it should be with hinges in here. Therefore, we can go back to the add-on building stories and switch that off and select OK again. And then it is, the center of mass is gone, and the center of mass is still there, but the rigid couplings, they are gone. And everything else you still have in here. of course, as usual in our software, it is possible to switch that all off and on in here. Let's say dimensions or whatever you can imagine what is there. So that is already just let me look at my documents if I did not forget anything. Yeah, that's already it for the input of the building model add-on. And I now want to show you the results that it's generating. Of course, what is not possible in here to calculate this building, for example, with the combination 5, where we have the highest wind load. Maybe just a short introduction also to the load. So there's self-weight in here with 1 kilonewton per square meter in each story. Then we have quite a whole bunch of live load on every story, and the wind load is just hold on. It's just 2 kilonewton per meter on every length in here. So just that we have a horizontal load on the structure. Okay, and now, you probably would agree that interesting would be the combination 5 and maybe the load case 6. And that is what I let the software automated, and I will just move that in right now, just to give you the results on it and to show you what the building model has changed in here for this. If you watch the other webinar, there's all this stuff with releases and all the other forces that is explained here. But what I want to show you is what we have here at first in the mask. So we have the action in each story. Now for load case 6, the wind load, because it's quite simple to see because we have only the load in the global Y direction in here. So that's also the story forces in here. And that's an information you could also easily use for your dynamic analysis. And you see how the forces increases to the ground floor. Then we have the deformation in each story. The center of mass, of course, you have that also graphically, but you get here also the ladders of the center of mass, so that you know the origin with exact decimal places. And the forces and shear walls I can show you actually directly in the GUI as well. It is automatically generated here in the results sections, just the stories. And if we switch on just the stories in the ground floor, you see that you have a force per each story for each wall in here. So I just switched on story the wall 1 and 2, and you see that this is the force that is in this complete wall. We can of course also select different forces of it, but I think right now it should be enough. I don't want to overdo it in here. Okay, that was anyway not very interesting. Maybe if we look for the shear force in X, that is something you may want to read out. Okay, so this is what you could already use in our software. And now I want to demonstrate you what you can look forward to in a few weeks or months, maybe. Therefore, I will now model something from scratch again. You see that I started now a pre-release version, so that is nothing that you can download. Rename it the new position building model, BM probably. 3D, that stays. I will not switch on the building model. I will do that afterwards just to show you what it is doing. I can switch on the stress strain analysis, for example, just to show you how to design it. We did this webinar on Tuesday for the German customers already. they did not have it, but I decided that this is maybe helpful to imagine what this is doing. Okay, so then we select OK. And the building should have the dimensions 15-meter length, 8-meter width, and 4 stories, and each should have the dimension of 3 meters. So quite a simple building. Yeah, the X direction, we want to have 8-meter length. We don't want such a thick wall. We will make it from concrete, of course, but maybe not so thick. So let's take 11 centimeters. All right, concrete, and then okay, here and where was it? 8-meter and 3-meter height, and in the other direction the 15-meter. So origin here and 15-meter here. Then we will copy that to the inner side by 1 copy and distance from 7.5 meter. We will also add some openings in here. Just, yeah, very simple openings in here, there. We'll do also the same, or not the same, but we will also put openings in here. So therefore we should get the other working direction. So this, and this, and here also something here and there. Perfect. And then we can copy this one. Oh no, not copy. We should mirror this on XZ plane by this distance. All right. Oh, too bad. I should have activated also the openings, but now I can do that, and it saved all my inputs that I had. Okay, so this is the ground story. Well, it's open on one side. That I should change. 11 centimeter and tuck. And maybe we make a thicker surface on the top with 20 centimeters. We can just keep that. All right. And we make a bigger opening here just for the ground floor, just that it's not looking so, yeah, just a little bit more terrific. So we take the origin in on this point and this, and zoop, zoop. So, oh, hoppla, choose the wrong one. Hold on, what did I do wrong? So the new one should be here. Yeah, I did not select it. So think, yeah, if we look for it now it works. Okay. Strange. Where are we? There and there. We are somewhere in the, yes, now. Come on. Zip. XYZ. I take a new origin. No problem. And this one should have this center here and the other ones there. Okay, set active. Okay. For some reason, it's not doing what I want it to do. Okay, no problem. We will copy that. Actually, so move copy in Y direction -4 meter, -4. And this one then in 3 meters in Y direction plus. Yeah, now a little bit more effort, but I think it's good for you to see how to do that. Oh wait, we can actually move them or copy them upwards, 0 and -2 there, and then we can choose the opening with no problem. So there you go. And now we can select the opening, and now we can mirror it. Choose this one and say we want the exact plane. It should be good. Perfect. And now we want supports. Oh no, before we make the supports, we will copy it in one story. I will directly explain why I'm just copying one story, -3. Because the reason is that here we can argue, okay, there should be some additional stairs to reach the flats in here, but here we do not want to have a balcony, and therefore we say to divide it, we say we remove the opening, or we make the opening more narrow. Again by one copy and -1 meter. All right, and oh no, this is also two. Divide, and now we can choose the openings or the lines of the openings. Delete this. Tick, tack, tack, tack. Okay, and one more time. Okay, and then the opening is there. And the same on the other side. So, okay. Oh, there was one less. Okay, this. So now it's there. I will leave these openings here because this nodes I can leave here because I actually need them for modeling my story cells. I will model them, and then when I have modeled them, I will show you actually what this is doing. So first of all, we will copy this in y direction by 1 meter by 2 copies, right? So on this side, so just you can see it, and I will also switch on the rendering. It's just looking a little bit nicer. And also here, move copy, I think 1 copy. I'm not 100% sure. Yeah, 1 copy. Nothing in that direction. 1, 0. This one, and then -1 meter in the other one. And we can also use drag and drop, but we can also use copy. From here to here. Okay, I agree that this is now a little bit of a modeling issue, but it's worthwhile spending the time. So, okay, and I don't think it's too much time that you are using in here. There, and this is in the X direction by 2 copies and the meter, and 0 here, all right, and the same on the other side. We'll also grab this outside corner in here, all right, zack, and -1 and 2 copies. All right, think we have them all if I look for that, except this ones. These ones we still need. Okay, no problem. One will be enough, and yeah, that's what I meant. Now I can just directly use this node in here. It's just helping me a little bit. So okay, and then 1 copy. I know the value already. It's 3 meter, but yeah, I can also choose it from here. And now really the last one is from this point to this point, and now that's done. All right. Okay. I will do, how's the English word for that? I will do connect selected lines and intersections. Then I will add the supports on it, the line supports. First of all, I will assign line supports with a support in Z direction and the small spring in X direction. I will choose them local and yeah, just assign them to the ground. Okay, done. On the openings that goes through the ground, I will delete the supports because it makes no sense to have supports there. Okay, okay. And so we have this, and what else do we need? So yeah, I want also to add some wind load on it. Therefore, I need local supports in here just to fix them there. Hopefully statically determined and not over determined, or maybe not many times over determined. Therefore, the first support I'm fixing in X and Y direction. I want to assign the wind load on the weak side of the building, so therefore I will just support it in here, and the other side I will make a new nodal support that's just fixing in the X direction. All right, right. So maybe I can increase the size a little bit. So that's too much. Whee. Okay, there you go. That's it. We can also maybe generate the FE mesh just to see if it's good what we have done. Looks great, but for now I don't want to see the FE mesh, so I will switch that off. Okay, and we will now copy the missing 2 stories. Via here, now we can use 2, and then there's Y0, and here minus 3 meter. That's okay to delete the mesh. So you see, that's it. We will put some supports we did. We will put some force from self-weight to it with a value of, let me see what I choose here, just that your downloaded file contains the same load, 2 kilonewton per square meter. So this and this, and we go again in this direction, swoops, swoops, and swoops. In the file that you can download after the webinar, I did not load the top story. So yeah, in case you want to really compare all the results, you have to add that there, or maybe we can use this other model. So this, and also I have to add 2 new load cases. That should be enough then. For now, the second one should be live load, and the third one should be wind. All right. So first of all, the live load. Live load, that makes sense to only have in not in the top floor, but in every other story. What did I choose? The 5 kilonewtons, so quite a high load. 5 kilonewton per square meter, and I will again assign that here, here, and here. All right. Okay. So maybe we switch off the rendering because you see right now nothing. So now I think you can imagine the load on it. And the wind load, I will add with the wind load generator. Therefore, I go to the load wizard, wind load, new load wizard, and I will, as I said, let the wind blow on the weak side of the building because that's probably design giving. Zoop. Tuck, tuck. Oh, wait on. I made a mistake. Hold on. So this and this one. Okay. Now it works, huh? Oh, but it was this way, this way, this way, this way. Yeah, looks good. So as I said, just on one side. Yeah, wind loads themselves are explained in all the other webinars anyway. So just for you to imagine, that's now the wind load on it so far. Yeah, now we can actually activate the building model add-on. But before, I also would like to take a short look to the load cases and combinations. The only thing I'm doing in here is that I will switch off the serviceability limit state SLS combinations, and I will just generate ultimate limit state according to first order theory in here. So now they are done. Probably what we would be interested in is this combination because we have the highest wind load in here. But in this smaller model, it's possible to look for all the results, no problem. So yeah, that works. Before we switch that on, we can still use the connection function again. Did not change anything. So, and now we switch that on and go to building model add-on. You saw that already in the other model, and so far everything is as what you have in your customer version. But now you see that there are some changes. There are now cells generated, and that's the reason why I modeled all these lines on every opening in here. With these cells, it is called, let me look for the English word, it is called special objects, surface cells. Oh yeah, that's simple. It's the same in Germany. So surface cells, also in English, and with those you can determine where you have your forces that are running through the building and where you want to read out those forces. That's the important thing. And which of these elements you want to design. If we look for this building, and we can maybe switch the other rendering on. Now, what is probably the most interesting part of this? I mean, there's this spandrels in here, top and bottom of each ceiling. That's probably interesting to be designed, definitely in the ground floor. And I mentioned it now already several times. The weak axis is the most design-giving surface for the wind load. So we probably want to verify the force that is going through this, and this cell. Everything else so far is really not my interest in here. I mean, we can, or you should verify them all, but it's really not necessary. And that's what the idea of this building model is. Okay, first of all, we again have to select building stories. If you look for the entry here in the data navigator, you see that's the same dialog, building stories, but there are 3 more additional objects: floor sets, shear walls, and spandrels. I will explain them after I have created the building stories. Once again, that's now the same of what we had. We take the top elevation by 3 meters and generate it. But already here you have quite an interesting option. It's called floor modeling, and it looks the same as what you have in the customer version with story slab stiffness. But the difference is that floor modeling is now possible in each story. If you think back about the Brook Common building that I just showed you in the beginning, for the concrete in the first story, it would have been perfect to assign rigid diaphragm there, because there you have it connected rigid in each story, and that would definitely make sense. Here right now I will switch that off. The rest is absolutely the same, and I will select all 4 stories, and I will just use the rigid diaphragm on the top of it, because I want to show you what it is doing. We press OK, and you see it's not in the other stories. And if you look for the surface in here, it has the stiffness type standard. And now, because of the building model add-on, this surface in here, oh, hold on, how can I attach it now? Here. This is now overwritten by the building model, and it's a floor slab, which can also be used for the design process later on. Okay, so that's one of the options. Then, because I choose this first or this top story in here, I have also a floor set assigned where you can see what surfaces and maybe members, we do not have any members in here, are connected to it. So that's one of the possibilities. Okay, for now we will switch that off and go and generate the floor, sorry, not the floor set, the shear walls. The shear walls, I mentioned it already, I'm interested in this cells in here. I will select them and go, well, select this cell, this cell, this cell, this cell, all right. And now in the background, there is already generated a result beam with, yeah, if you know the result beam in our software on which you can design mainly the concrete buildings, but also any other elements quite easy. Generate result section means that it's additionally then generating result sections on it, but we actually don't need it. And here I will show that to you after I have generated them. So, and then we take the other side because it's relevant as well. Here, here, and here. And just to make a very fancy section, I will also make a little angle in here just to show you that this is also working and can be designed then. So I take them now here over the corner. Zack, right? Takes a little bit longer because now we need to, in the background, start the error section software and generate all the section values of this section, of course. You can also take a look to this. Looks like this. All right. That is the shear wall design. Okay. Now, yeah, when we look for the most simple result section done in here, you see this is the result beam generated by the building model add-on. It's because of the surface cell 3 in this case. Here's the section. Okay, there's nothing special about that. And here is the stress analysis configuration. And now if we would say yeah, I don't know, probably normal force is something that's definitely design giving in here. I have absolutely no imagination what value we will have there, but let's say we make, I don't know, 240 Newton per square millimeter just to see something. And well, we can actually keep that. Maybe no, we get that. It's just for showing you that you can use this for designing the member, the result member in here. Okay, that is actually it, but I forgot the spandrels in here. And to show you what this is doing, I will also generate 2 new spandrels. The first I take for bottom and top spandrel. All right. And the second one I will take on the right side, just the bottom spandrel. The reason for this is that now I think you can easily see that you would have quite a higher moment in here, but a higher normal force in here, because yeah, definitely this is in the neutral axis of this spandrel. If it's not connected to the other elements in here, you would have it like perfectly. And this also can be verified for the design process similar than the other one. Okay, this, and we will, wow, we can also say we will calculate just the wind load and this for first glance and look for the results in it. Okay, there we have the results. Where are they? Here, static analysis. Why is it not switched on? Ah, there you go. Okay, so this is the wind load. If we look for the columns, again, yeah, that's the same as what we have already had in here, but you have now the other option. I will switch off actually the sections in here and will activate the member forces, and I will also switch off the rendering. So because not the normal force in here, but the horizontal force can be probably quite interesting. So you see that's the shear force that's going to each story of your building. And if you look for the local deformation, yeah, okay, that's quite a stiff building, but you see it also here, that this is the deformation in it. And if you look for just the corner, the little angle that I generated, maybe we can just select this for visibility. You see that also there you have all the internal forces in it. We can also take a look at this combination in here. Oh, it's not done. Why not? I think I chose it. Okay, there it is. We will switch off the visibility, and here you see quite a higher normal force, of course, because we have now all the vertical loads in it. The deformation on the moments itself are the same. I forgot to show the spandrels in here. So there's spandrel 1 and 2. So you see normal force, nothing so serious in here, of course, because we want to see the moment that's coming from top and bottom on it, and how this can be used for the design process. Okay, the stress strain analysis. Therefore, I will just take a short look to the load cases and combination. Wow, it should be good. I don't know. Yeah, it's good. And we go to stress strain and maybe select just one of the spandrels. This one, number 30. Calculated. I just have now one stress limit defined here, so it definitely makes not so much sense. As I said, I just thought about it, I don't know, an hour ago or something like this. Yeah, so you see, there's actually no result, but yeah, here for this limit, for the normal force, which we do not have in here, you can see the results. It definitely would have made sense to, I don't know if we can go into this. Oh, we have to We have to use the result beam. I think it's probably not worth investing the time in this right now. Spandrel 1. Yeah, number 3. 13, sorry. And if we activate now, the moment in here is, oh well, we can use the one that's actually, I don't know what it's doing there. We will also use the user 1, something like this. Hope it's correct. Just give it one more try. Right. Yeah, you see, yeah, not really loaded a lot because the wall is quite big and the moment is not that big in here. Definitely the concrete add-on would have been nicer for this. Anyway, that was it, and I would give the screen back to Jasmine.
Thank you very much, Bastian. I'm going to take over the screen again. 1 second. Okay, great. Before we end this webinar, I'd like to remind you that you can always book a free online appointment with one of our sales experts. If you have any questions about our program or any add-ons, like the one we use today, for example, you can book a product demonstration or have them make an offer for you for anything you'd like to buy. So before we come to an end, I'd like to show where you can find the recording of this webinar on our website. So therefore you go to our website, dlubal.com, you go to news and events, webinars. So here you see today's webinar. Next week, we're going to talk about our Win 2. If you'd like to attend this one, for example, and if you enter today's one, in the upcoming days, the recording will appear here. Your certificate will be sent together with a link to this recording via email to you also in the upcoming days. Here you can find the presentation used today. And here you can find the model we used. So I'd like to thank everyone that was here today for attending. I'd like to thank Bastian for his nice presentation. And I'd like to thank Stefan for answering all the questions. I wish you a nice week. And after this webinar, there will be a short survey that you can answer to ensure our quality. And I would just like to tell you that the highest note is 5 and the lowest is 1. Thank you very much. Goodbye.